All right. Actually, before I show you how you can connect to a database, let's kind of spend some time talking about kind of databases, or to be more precise, relational databases, which are the databases that we're going to study in this course. Um, so I think I mentioned last week that databases essentially are a place to store data, and data is everywhere nowadays. I mean, all companies store data. Data can be very insightful, especially with the technology that we have nowadays with machine learning, data mining. So it's important to collect data and use it, hopefully, if we can. For example, my website, the website that maybe we can use that as an example. Let me open my website and I'll show you kind of an example. Okay, let's see. Open the chat window. Okay. So all of you had to sign up to the site. And of course, you have your name, first name, last name, email, you create a password, and then you pick a semester, and you pick the right section, hopefully, and you enroll. Now, when you do this, I store the data, of course, because I need to be able to allow you to log in. This data has to be stored. And this data is stored in a relational database, which means that in a table format, so many tables. So let's try to kind of reconstruct that, just to kind of get an idea of what some of the problems that we're going to encounter are. And those problems are problems that we're going to have to fix during this semester. Okay, let me do, well, that's fine. I hope you can, I think I can do this. Okay. So we have first name, last name, email, password, semester, and section. So let's think of this as a table. So here, I'm going to create a table, and I'm going to change this to make it landscape so that we have more space. So maybe here I have kind of first name, last name, email, password, and then maybe semester, kind of semester, maybe section. Okay. Now, it's good if I store more data, but for now, let's just say that's what I'm storing. So there's a bin here, there are values here. I don't want to kind of spend time putting values here. Now, the password, of course, will be different than the password that you enter. I don't know if you know that or if you've studied security before, but passwords should never be stored in kind of plain format. They have to be, we have to change them to another format. And I only store the password after that function. So we have to do something called hashing. And essentially you have a password, maybe it's 5-6 characters. The hashed value maybe is going to be 60 characters or 50 characters. And there's no way, it's just impossible for me to go back from this hashed value to the actual password. That's just impossible. So if you go to a site like Facebook or any other site and you put your password, nobody can see your password. Nobody sees it. And if you try to reset your password, nobody should tell you what the old password is because they don't see it. They don't have it. And if someone tells you what the old password is, that means the website is very insecure. You should never want to kind of sign up to a website that stores your passwords in kind of plain text. I mean, it's going to be text, but in plain, kind of in the actual form of the password. So I store all of that. But after some time, I start realizing that I need more data. For example, it would be actually nice to put the university. Maybe I teach at different universities. So maybe it would be nice to have a university here. Maybe it's nice to have, instead of semester, maybe I can say year, and then I can have semester. So like that, maybe that would be kind of 2021, and that would be fall. And maybe it would be nice to actually talk about the course too. So what is the course number? That would be, of course, ITCS 3160. And as you see, as you're kind of noticing, there's a lot of information that I need to store. And the problem with doing it this way is there's going to be a lot of repetition. So for each student, this information will be kind of different, but then all of this information will be the same. Is that good, guys? Does that make sense? That's kind of problematic in databases. Because first of all, that'll take so much space and that'll make everything slow. Let's maybe add another word. Let's say time. I want to add the time. And let me add the days. All of that is very useful information because maybe I want to search. I want to say, well, using my system, let's look at all the courses that I teach on Wednesday. So I do need that value so that I can find all the courses that I teach on Wednesdays or maybe Tuesdays. So let me kind of ask you one more time, and let me this time get some reactions, hopefully. So is it clear that there's a lot of repetition here? So those will be unique for each student, each user, but those will be repeated for all of the users that we have. And that's a problem. I mean, maybe you don't know how problematic that is, but hopefully you have a feeling that this is not a very good design. So how do we do it? We actually split this table into two tables. So we say, I want to have a table for users or students, and I want to have another table for section or course, maybe. Let's just say course. And for course, I'm going to create a table. And this one's going to have all of that. So how many do we have here? 1, 2, 3, 4, 5, 6, 7. So let's do 7 of those. I'm going to copy that. And I'm going to create 8 different columns. And I'm going to paste this here. And I'm going to get rid of all of that. So for this table, I'm going to have a single row for each course. So I'm teaching, 20 here, fall, section, yours is 52, right? And then University on CC, courses ITCS 3160, and time is going to be 11:15, and days is Wednesday. I do have another course, another section, so that'll be 2021. That's going to be fall, that's going to be this one's going to be fall, this one's going to be 53. Also UNCC and ITCS 3160. I am recording, right? Okay. And the time, this one's actually online. And the days, that kind of doesn't make sense because it's kind of entirely online. There are no days. Now you notice here that I left one column blank because this one's going to be the ID. So I'm going to create an ID for each different row, and this ID is going to be unique. So I can start with 1, then I can go 2. I don't have to do 1, 2. I can just give it any IDs, but it's going to be unique. I'm going to get rid of this. Let me get rid of this. Delete row. Okay. Now for this table, of course, I need to know which course each student is signed up to. And that's important. So I need to create a connection between these students and this courses or this course table. So I can do that by adding a new column, just a single column. And I can say course ID. Do you guys see what I'm doing here? And I'm going to say, because this student actually is a student in this section, the Wednesday section, your section, I'm going to give it the value 1. Now, this student may be also in the same section, so that's going to be 1. This student is going to be 2. This one's going to be 2. So maybe those 2 students are in the second section, and the first 2 students are going to be in the first section. So that's how I'm going to do it. Is that good, guys? Give me a reaction. Do you see what I did here? I saved a lot of space. I came up with a new design. Instead of 1 table, 2 tables, and I created a relationship here. And this is how we're going to do things, in this course. We're going to have many tables, and we're going to connect them. And this takes a little bit of experience, a little bit of kind of sometimes it's art at the beginning, but we're gonna of course learn the basics. We're gonna learn what is an obvious kind of no, how we kind of split them into more tables, and how we make them fast. Okay, so there's a question: is the year table wouldn't need to be deleted? Oh, this year. You're right. This year needs to be gone. I forgot to delete this. We don't need year because we have year here. Of course, we have other information here. I need to know, for example, when you created the account, when was the last time you logged in? All of that, by the way, is in my tables. If I were to look at my website, just to kind of, without showing you a lot of details, I can tell you that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14 tables, actually 15 tables for this website. So this website, this website consists of 15 tables. I have a table for when you make a reservation, for when you make an appointment. If you want to make an appointment with me, there's a table for that. There's a table for quizzes. There's a table for questions. There's a table for answers. All of those have different tables, and I designed them in an efficient way, of course, that we, at least the intention was for them to be efficient, and they all have connections. So those 15 tables, they're all connected. And 15 tables is not many, by the way. I've had way more than 15 in the past, and companies have way more than that, of course. And they have a design, they design them. There are kind of ways to describe the design. Of course, we're going to learn how to implement them after we design them. And we can design them on the fly too. So we don't have to kind of start with the complete kind of design, then write the code that will create the table. No, we can just come up with a design. It's an iterative process. So design is an iterative process. You start with something, you like it, you don't like it, you keep changing it, and that's how people build systems. Okay, guys, do you have any questions about this? This is just, I think we can call it an introduction to kind of relational databases. I'm going to actually create a very short video for that. So I'll stop the recording after we're done, but I do want to hear your questions. So Aiden is saying about the password thing, what about websites that will tell you that you entered an old password, telling you to use the more updated one? Would that be insecure? No, that wouldn't be insecure, because if you give me an old password, I can hash it and I can compare it with my old hashed values. That's actually fine. So again, you come up with a password, I hash it, I end up with maybe 20 or 30 characters, and maybe I can save that. That's actually not bad. When you try to change your password, or when you try to update your password, I can look at the hashed values. And if any of them matches the hashed kind of new password that you gave me, then I will tell you. That's not insecure. That's fine. That's good practice, actually. You don't want to, I don't do cybersecurity. I don't really teach it, and I haven't done research in it. I think it's interesting, but it's not something that I would say is kind of one of my expertise. But of course, we all know that you shouldn't use the same password. You shouldn't use a generic password. So these are things that we know is kind of true. So let's see. Loai has a question. Loai, what's your question?
My question was, what was the reason you were saying you had to create different different tables, or why couldn't you have just put all those columns on the same one?
Okay, so that's a good question. It's kind of, so why would you do that? First of all, size-wise, if you count the number of kind of fields that we have, this one will be much less, because we only have 2 rows for those. So we only have 2 rows. So otherwise, you're going to have, let's say you have 200 students. Each one of those students will have all this data. So is it clear that it's less data?
Yeah, for the course for the course table, yeah, it's clear.
Yeah, it's less data because if you want to put it in one table, you're going to have to repeat this data for each student or each user. So that's a lot of repetition. So one problem would be that's going to be more space. So the table is going to become big. And when something is big, it's actually hard to search. The second other problem would be to update. Let's say you want to update, let's say they decided to change this from 11:15 to 11:30. Can I mute your mic because it's kind of, can I mute you? Yeah, you can unmute when you want to kind of follow up. Um, or maybe you can, Parker saying you can do the push to talk. I haven't used that, but you can mute and unmute. That's fine. Okay, so another problem with what Loy is saying is if you want to update something. So let's say you want to update this from Wednesday to Thursday. Let's say I'm creating this, and 1 week before the semester started, they told me it's actually going to be on Tuesday. If that's the case, then we're going to have to go through all of the elements and change all the W's to T, to Tuesday, or maybe to Tuesday, not T. And that'll be a lot of work. So that'll take time, that'll be slow, and that's error prone. So it's easy to make actually mistakes that way. You don't want your code to be error prone or your design. You want it to be kind of reliable, robust, and hopefully it's not easy to kind of break something in your design. So Paul is saying we can think of ID as a pointer, and that's perfectly fine. So if you want to get, let's say we have a student here, let's say we have Alan here. If you want to get this information about the courses that Alan is enrolled in, or the course, the single course in this case, all we have to do is just find this value, look for one here, and then get this data. And we know that Alan is right now enrolled in this course. So yes, it's relational because we make relations like this and we create those kind of connections or pointers. So that's how we do it. Do you guys, does that make sense? Do you have other questions?
No, that makes more sense. Thank you.
Okay, perfect. All right, so Dananji is saying, does the hash code update when the pass is changed, or does the new password point to an old hash? No, so the question, guys, let me kind of tell you what happened here. So let's say you create a password. Let's say my password is Ayman. Now this one can become a number. It's easy. It's easy to convert this one to a number. We can talk about that later, but let's say I'm going to convert that to a unique number, and that's easy. It's going to be a very large number, but I can convert that to a unique number. Maybe that unique number is going to be this. And what I'm going to do is I'm going to take this, multiply it by some number, add some value to it, and then mod it. So let's say I do that and I end up, let's say I'm going to just mod it. I'm just going to simplify this a little bit. So I'm going to take this and I'm going to mod it by some value, let's say 100. Of course, if you mod it by 100, you would end up with 31. So that's going to give you 31. So let's assume that this is what I store in my database. Now, again, those numbers are very small. We're not going to store just 31. We're going to store a much larger number. 31 is a very small number. But let's just say this is what's going to happen. You take this one, you mod it by another value, you end up with a value, and this is what you store in the database. So my password, which is Ayman, is going to be 31. So that's going to be stored here. Okay, guys. Now, let's say you want to log into the website. You're going to put Ayman, and my website is going to take this, and it's going to apply the same function, which in this case is just modding. And then it'll come up with a value, which happens to be 31, and it'll say, does this match what I have in my database? And if it matches, I'm going to say go in. Now, again, here I'm kind of simplifying things because it's a little bit more complicated than that. But what I'm saying is really the core, the kind of the most important part. There are many details to prevent things, but what I'm talking about here is really the most important part. So if you understand this, you really understand how it works. Let's say you want to change the password. Now, what someone asked, let's see, I think Aiden asked, let's say I change this password to something else, let's say table. Okay, table is going to have, of course, another number, maybe this number, and we're going to hash it. Hopefully there won't be collision. So you hash this one, which happens to be modding, but for me, just modding by 100, it's going to be the same function. And that's going to give us 37. And of course, because my function is very kind of naive, there would be collision maybe, but let's assume that there's not going to be any collision here. Meaning collision means you're going to end up with the same number. Let's just say I'm going to actually mod it by 1,000. And if you mod it by 1,000, that's going to be 231. And here it's going to be 237. So at least right now, it's harder for a collision to happen. And let's say after 2 years or 1 year, you decide to use Ayman, which is the old password. Now, my system can say, okay, Ayman is going to have the same, number, going from this to the number, there's going to be a function that takes the ASCII code of those characters, raise it to some power, maybe add them up, and you end up with a unique number. That's easy to do. And when we take this and when we apply the function, which is hashing it by 1,000, that's going to give you 231. And when it gives you 231, and assuming that maybe you're storing the old hashed value, so let's say you store the old one. So I have another table, old password. Okay, and I'm saving the passwords for different kind of users. So here, maybe I'm going to have an ID. I didn't really want to do all of that, but let's say I'm going to have an ID for this one. You should have an ID for each table. And let's say Alan has ID 1. And here the old password is going to be maybe old password. I can do it, but I think it'll confuse you. So let's forget about this kind of table. Let's say I have this stored. I'm storing the old hashed values. So 231 is stored, 237 is stored. And when I ask you to change your password again, you're going to give me Ayman. And I have the number here. That's easy to get because again, that comes from the ASCII codes of characters. And the function is going to be the same, which is modding it by 1,000. So I'm going to end up with this number 231, which happens to be the same as one of my old numbers, which means that you're using the same password. I mean, you're trying to use one of the passwords that you used before. And this is not very good. I mean, sometimes until you change it to a new password so that you keep everything secure. And I can tell you, wait a second, this is a password that you've used. Even though I don't have Ayman stored, because this password was hashed to a number that existed in the past, that means this has to be Ayman, unless there was a collision. But there's not going to be a collision because you can prevent collision. So this idea of having another kind of password that collides with the same number is not going to happen. That's going to be something that we're not going to discuss now, but we can prevent collision. So we know that the reason that you ended up with the same hashed value is because you have the same password, and at that point I can say, you don't want to use Ayman, you want to use something else. Is that good, guys? Does that make sense? Don't worry too much about that if that kind of didn't make perfect sense. I hope it did, because otherwise, you see some students may be, okay, it didn't make kind of perfect sense maybe to all students. That's okay. We don't need to worry about this. I mean, this is, Loa, you have a question?
Oh yeah. I just wanted to ask, what did you mean by collision with this?
Collision is when you have multiple numbers that hash to the same. For example, if I give you this value, this number, if you mod it by 1,000, you're going to end up with the same value. If you mod this by 1,000, you're going to end up with the same value. So we call this collision, because you have multiple values that are hashed to the same value. And that's going to be a problem, because maybe you're going to give me another name, like maybe mug. I'm looking at what's around me, and that's going to be, let's say, mug is very bad. Let's say water. And maybe water gave you this number. When you converted that to an ASCII numeric value, it gave you this one. And when you hash this one, it gave you 231, which is the same. Let me get rid of this, which is the same as Ayman. And right now the system is going to tell you, wait a second, you can't use an old password. But this is not an old password. This is a new password. The old password is Ayman. So you see, this is bad. So collision, we don't like collision. We prefer kind of to avoid collision. And we can, for the most part, say that collision is not going to happen. I mean, we can make it so unlikely that a collision will happen, so it becomes almost impossible for a collision to happen. So again, that's a detail that we don't need to worry about for now. But does that answer your question, Luai, about collision?
Yeah, that makes more sense now.
Okay, all right. So, okay, guys, I know maybe at least one didn't make a lot of sense to at least one. That's okay. You can watch the videos again. We don't want to talk about that. Just, I want you to know that what's stored in the database is not really the password that you put. It would be bad if that's the case. You can put a password here. I'm not going to store, that password in my database. I don't do it. And any website that does it would be a very bad website. Okay. Do you guys have any questions about this? Okay, guys. So I'm going to stop the recording because that will be the section that I'm going to call kind of introduction to databases. It's kind of very kind of basic introduction to databases. Let me stop the recording.